So welcome to the first year physics labs at York University. What we have here in front of us is an apparatus that many of you will be familiar with, having done this experiment in high school. This experiment is an experiment on linear accelerated motion. We are going to time the change in position of this glider as it accelerates down this frictionless inclined air track. You'll notice we have a jack at one end of the air track, which we raise to the desired inclined angle. And this air track has little holes in it where air will be forced out using the air supply that's attached here to the wall. When you turn on the air supply here, so the angles on both of these hoses are parallel to the nozzle, so you have a maximum amount of air coming out these little holes. This glider will be free to accelerate frictionless or near frictionless to the bottom of the air track. The reason it does this is that this glider is no longer in physical contact with the air track because it's now floating on a layer or skin, I guess, or layer of air about the thickness of a piece of paper. So there's no physical contact. And because it's experiencing a component of the force of gravity downwards, it will accelerate down the inclined air track. So this is the apparatus that we're going to be using, which I won't describe in much detail. And even though you have done this experiment in high school, this year we are going to use it to introduce you to some important concepts that you're going to be using not only in this experiment, but all remaining experiments that you're going to be doing here in first year physics. In your lab manual, before the start of the experiment, there's a section called Measurements and Errors. We're going to use the information in here to allow us to estimate what our errors are in our measurements. And then we are going to, later on, do simple error calculations using our measurements with errors in them. And then later on still, we are going to plot our errors. So not only are we going to learn how to take error measurements, do simple error calculations, but also plot our uncertainties on graph paper. In the past, you used to have single points, ordered pairs, that would represent the position and the time of your glider in this experiment. But because our time is not known precisely and our position is not known precisely, each point will have these error bars. And these error bars are closed with lines at either end. And basically, excuse me, what they tell you is that this data point could be anywhere within this error box that you have here. Okay. So come around to this side. We're going to use this computer, which will be interfaced with our sound probe. This sound probe is set to send out pulses, audible sound pulses, at a rate of 10 per second. It's attached to this interface box here, which is attached to our computer. And in real time, we will be able to see how the position of the glider changes with time. So let me show you how, what program you're going to use and how you're going to run this experiment. You click on a program called Logger Pro over here. And once you open it, you get the general template file, but this is not the file that we want to use. So you click on File, click on Open, select a file called Linear Motion, and open it. And you'll notice that this file allows us to collect data for a little bit more than 1.5 seconds for an air track that's up to 2 meters in length. Our air track that we're using today is a little bit less than that. So, how do we actually run the experiment? Hold our glider to the top of the air track, turn on the air supply as before, And the first thing you do is click on experiment and then click on 0 while holding the glider at the top of the air track. When you click on 0, what you have done is allowed the sound probe to set this glider at position 0. It's not about 30 centimeters away from the sound probe anymore. It's set to your starting position of 0. And then you or your partner can click on this green button here. And as soon as that green collect button turns red, that's when you or your partner will release the glider. So I click it, turns red, I release. So after the glider has stopped at the end of the air track, we go over to our screen and we notice a curve. This curve tells us how the position of the glider has changed with increasing time. We can rescale this graph by clicking on this icon here. It's a symbol of a graph with an A for auto scale. So when we click on this, we get this curve. The points of this curve, which will be plotted here, will allow you to form a second table for position and velocity. Once you create the second table of position and velocity, you are going to use the graph paper that is provided, and you will get a straight line that starts approximately at the origin. The reason it doesn't start exactly at the origin is because you may not have released the glider at exactly at the beginning of the data collection. Maybe you release a little bit sooner or a little bit later. But nevertheless, your slope will be a straight line. And the points that you plot here will have error bars around them. Why? Because of the uncertainties in our measurements that we are going to be using in today's experiment. And that's about it. Now, for those of you that want a little bit more information on how to perform this experiment, or to come and actually see and use the actual equipment that you'll be using in experiment number 1, linear accelerated motion, you are all welcome to come to the lab tutorials that this summer are scheduled from 1:30 to 2:30 on Tuesday afternoons. So if you want more information, we'll see you then. Okay, bye for now.